Okay, let's get started. With this problem, we have 3 gusset plates and it's just a normal gusset plate and it is subjected to 3 forces. So we have one in the y direction, it's 9 kilonewtons, then we have this F force. Yes, it has an angle, okay. There. Specify this tiny little triangle. Just so you know, these videos aren't planned ahead. I just grab a problem and we go from there. So that's my reaction is really genuine to this problem. Okay, and then we also have a force T, which we are supposed to calculate. All right, and they give the force F. Okay, great. And we also need the angle theta over here. So I think let's quickly just make our own free body diagram, because some of the figures here is a little bit small. Okay, no, we're not going to do it like that. I'm going to use dotted lines for the axis. So let's do this as a force. And we have another force over here. And then some tension force T, like this. And this is the x direction and the y direction. This is this force is F, this is T, and this one, let's just say it is 8 kilonewtons. This one is 9 kilonewtons, and I don't give it a name, which is a little bit annoying, but alright, that's fine, I suppose. And this one, we get the angle through this little triangle, which we were all introduced to when we learned about Pythagoras. Nice 3, 4, 5 triangle. And then we also have an angle over here, and it's theta. So we want to calculate T and we want to calculate theta. So, okay, this is going to be yes, okay, we'll do it in components. I won't go through the vectors, so we'll split it into components, because they say it needs to be in equilibrium. So I can say for equilibrium to be true, the following equation needs to be true. Well, following equations, in fact, because it's a vector equation, needs to be true. This guy. So the sum of forces in all directions needs to be a 0 vector. And then from there we get the equation that says the sum of forces. In which one should we do first? Let's go x. X comes before y. X needs to be 0. And that is also equal to nothing from this 9 kilonewton, but something from this F. So, and F in direction, F in the negative direction. So it's going to be negative. And how much of F? So we can see this nice little triangle. It makes our lives very easy, because the 5 is in line with the magnitude, the 4 is in line with the x direction, and the 3 is in line with the y direction, or parallel. So we can basically just say that the amount of force in the x direction is 4 over 5 times F. And it's negative, so 4 over 5 times F. And then we also have T, but it's not T entirely, it's the X component of T. Great. So from here, we can see that we can take this 4 to the 5f to the other side, then we get Tx is going to be 4 over 5 times the magnitude of F, and it's 8 kilonewtons, 8, which is then equal to, can I do that quickly out of my head? I don't feel like it. It's 32 divided by 5, I know that. So it's 6.4. 6.4 kilonewtons. Great, so we have the X component of T then, and now we can go on to the next direction. So we go on to the sum of forces in the Y direction. It's also equal to 0. And this time we have that 9 kilonewton, and the F force is once again in the negative direction. If you quickly take a look, it's negative Y direction, but this time it is 3 over 5 times F. And then let's see, the tension force, we specified it into the negative Y direction, so we should take it as I'm thinking now. No, I'm not gonna specify it as negative. I'm gonna say positive. Reason being that we'll most likely anyways get a component that is in the negative Y direction, and then my Tx and Ty aligns with my coordinate system. So I'm going to leave that as is. It should be in the same direction, but we can just check it afterwards. So I'm going to say plus Ty. And then we get that Ty is equal to, we take all of this to the other side of the equation, so that is 3 over 5, the magnitude of F is 8, and then minus 9. Over 5 times 8 minus 9, that's going to leave us with negative 4.2 kilonewtons. Okay, great. So we're almost done. We now have the two components. So now we can go and calculate T, and we can say that T will be equal to Tx squared plus Ty squared, the root of all of that. All right, and then let's see, 6.4 squared, and it doesn't matter what sign this is, we're only interested in the magnitude. 4.2 squared, we take the root of that, and what do we get for T? 4.2 squared plus 6.4 squared, and that should be 7.655 Newton. I'm once again going to 4 significant figures, just like in the previous video. Alright, great. So now we have the magnitude, but there's another thing we can go calculate from these components that we now have, and that is the angle between these two. So this angle we can essentially split up into two parts. Because we need the theta one, so let's make this horizontal line. It might be easiest to say, let's go calculate two angles. One is for this little triangle with the 3, 4, 5, and we can specify that angle to be psi. And the other one is in line with our, let's make it like that, tx, ty coordinates, and we'll call that theta. Or do we already specify the angle as theta? Let me just quickly go check. Oh, we already meant to calculate theta, so let's not call that theta. Let's call that something else. We'll call that alpha. So if we calculate psi and alpha, then we have the angle theta. So we can just say this next to here, alpha plus psi. That'll give us theta. Okay, and theta is relatively simple to calculate. That's going to be arctan of the y component minus over the x component, so that's 3 over 4. And then we also have alpha, and alpha, the angle is going to be arctan of ty over tx. And now when I'm talking about ty and tx, we just need to specify that these guys need to be the absolute value. Because if we throw a negative in here, we are going to have issues. Great. So then theta can be equal to arctan of 3 over 4 plus arctan of ty. What's the magnitude? That's 4.2. 4.2, and if I remember correctly, the x1 is 6.4. Let's quickly see. 6.4. Excellent. Okay. And now we can go and calculate that. So that is arctan of 3 over 4 plus arctan 4.2 over 6.4. And then we should get a value of 70. Let's do that. 14 degrees. Great, so now we have everything we need, I think. We went and calculate the determine the tension force T. Yes, we did that, and its angle for equilibrium, and they specify which one it is. So we have T. T is going to be 7.655 newtons, and then the theta is going to be 70.14 degrees. So that is it. And if we really want, we can write this out nicely. We can say that T is equal to, let's make a T vector. T vector is equal to 7.655 kilonewton and then we need to specify the angle because we said it's a vector at 70.14 degrees, let's say clockwise from, let's write this down here. No, let's keep going over here. From F. Great, and there you have a nice little neat answer for that entire question. Yeah, that's it.